East Moline, Illinois, 1977. Inside a nondescript industrial garage, a door opens. Daylight floods in for the first time in nearly 20 years. What emerges will bankrupt some companies, force others to spend hundreds of millions in emergency response, and completely reshape American agriculture. 1 mile away, John Deere's engineers arrive for another day of work, building the best conventional combines in the world. They have no idea they're already obsolete. The machine rolling out of that garage, the international harvester Axial-Flow, represents 2 decades of absolute secrecy. Frosted windows, locked doors, a handful of engineers sworn to silence, all working on a technology so disruptive that if word had leaked even 5 years earlier, it might have changed everything. But the secret held, and by the time the competition found out, it was already too late. The problem with conventional combines? To understand why the Axial-Flow was so revolutionary, we need to understand what came before it. By the late 1950s, the combine harvester had already transformed American agriculture. These massive machines could cut, thresh, and clean grain in a single pass through the field. They were marvels of engineering that had replaced entire crews of workers and weeks of backbreaking labor. But conventional combines had a fundamental limitation built into their very design. Traditional combines used what's called a transverse threshing system. Grain moved perpendicular to the direction of travel. Here's how it worked. The header cut the crop and fed it into a cylinder that beat the grain loose from the straw. Then, and this was the bottleneck, the mixture of grain, straw, and chaff tumbled over a series of straw walkers, which were essentially mechanical fingers that shook the material as it moved backward through the machine. Gravity did most of the separation work. As the straw walkers bounced and jiggled, heavier grain kernels were supposed to fall through slots onto cleaning screens below, while lighter straw was carried out the back of the machine. This system had serious problems. In high-yielding crops or tough threshing conditions, the straw walkers became overloaded. Grain that should have fallen through the slots instead got carried out with the straw and dumped on the ground. Farmers called this lost grain, and it represented pure economic waste, sometimes hundreds of dollars per acre literally thrown away. The machines were also enormous. All those straw walkers, shaking mechanisms, and separation systems required substantial real estate inside the combine. Conventional machines were long, heavy, and difficult to maneuver. They were maintenance nightmares with hundreds of moving parts that required constant adjustment and frequent replacement. But perhaps most frustrating, capacity was fundamentally limited. You could only feed crop material into the system as fast as those straw walkers could handle it. Push too hard, and grain loss skyrocketed. Farmers were trapped in a productivity ceiling that seemed impossible to break. Engineers at every major manufacturer understood these limitations, but the basic design had been refined over decades. Millions of dollars in tooling and manufacturing infrastructure were built around conventional combines. Dealers knew how to service them. Farmers understood how to operate them. Changing everything would be an enormous risk. The secret garage at International Harvester's East Moline facility in Illinois. A small group of engineers decided that incremental improvements weren't enough. They needed to reimagine the entire threshing and separation process from scratch. Sometime in the late 1950s, the exact date remains unclear, IH management made a decision that would prove visionary. They allocated resources for a small research team to explore an entirely different approach to combine design, rotary threshing. The concept wasn't entirely new. Engineers and inventors had experimented with rotary designs dating back to the 19th century, but no one had successfully commercialized a rotary combine that could compete with conventional machines in real-world farming conditions. IH's team was given space in a garage with frosted windows. The location was strategic, just 1 mile from John Deere's combine manufacturing plant. The frosted windows weren't decorative, they were essential security. What was being developed inside had to remain absolutely secret, because if competitors understood what IH's was working on, they could begin their own development programs and potentially beat IH's to market. The team was working on something called Axial-Flow technology. Instead of grain moving perpendicular to travel like in conventional combines, the new design would process crop material parallel to the direction of travel along the axis of the machine. The heart of the system was a single longitudinal rotor, roughly cylindrical, running nearly the entire length of the combine. Crop material would enter at the front and spiral around this rotor as it moved toward the rear. Rasp bars on the rotor would thresh the grain loose, while the centrifugal force generated by rotation would throw the material outward against a concave cage surrounding the rotor. This cage had slots that allowed grain to escape while retaining larger straw particles. It was elegant in concept. Threshing and separation happened in one continuous operation, in the same chamber, with a single rotating element, doing work that previously required cylinders, beaters, straw walkers, and complex mechanical linkages. But theory and practice are very different things. The engineering challenges were immense. How fast should the rotor spin? What angle should the rasp bars take? How large should the cage perforations be? What about different crop types with different moisture levels and different threshing characteristics? How do you adjust the machine for varying conditions? And perhaps most critical, could a rotary system actually deliver better performance than decades of refined conventional technology? For nearly 2 decades, the team worked in relative obscurity. They built prototypes. They tested them. They failed. They redesigned. They tested again. The work was painstaking, methodical, and expensive. International Harvester's management showed remarkable patience. In an era when quarterly earnings increasingly dominated corporate decision-making, IH committed to a research program that wouldn't deliver returns for years. Meanwhile, just 1 mile away, John Deere continued refining and manufacturing conventional combines, completely unaware that everything was about to change. The reveal that shook the industry. In early 1977, International Harvester dropped a bombshell on the agricultural equipment industry. At dealer meetings and press events, IH unveiled 2 new combine models, the 1440 and the 1460. These weren't incremental improvements on existing designs. They were fundamentally different machines, featuring the Axial-Flow rotary system that had been developed in secret for nearly 20 years. The specifications were startling. The new combines promised substantially higher capacity than comparable conventional machines. Some estimates suggested 30 to 50% more throughput in comparable conditions. Grain loss was dramatically reduced. The machines were simpler mechanically, with fewer moving parts and easier maintenance requirements. Perhaps most impressive, the Axial-Flow design was inherently more flexible. The single rotor system could be adjusted for different crops more easily than conventional machines. It performed exceptionally well in difficult threshing conditions where conventional combines struggled: tough, green-stemmed crops, high-moisture grain crops with heavy straw loads. Early adopters reported remarkable results. Farmers who purchased the first Axial-Flow machines found they could harvest faster, cleaner, and in conditions that would have been marginal or impossible with conventional equipment. Word spread quickly through farming communities. But it wasn't just the performance that shocked the industry. It was the realization of how far behind everyone else had fallen. John Deere, Case, Massey Ferguson, Alice Chalmers, every major combine manufacturer suddenly faced an existential problem. They had massive investments in conventional combine technology. Their factories were tooled for conventional production. Their engineers were experts in conventional systems. Their entire product strategies assumed incremental improvements on existing designs. International Harvester had just made all of that obsolete. The scramble to respond. The response from competitors was swift and desperate. John Deere, which had arguably the most refined conventional combines on the market, found itself in an especially difficult position. According to industry reports, Deere spent over $120 million on rotary development during the 1970s, an astronomical sum for that era. But you can't simply copy a competitor's design. Beyond patent protections, there's institutional knowledge embedded in years of development. IH's engineers had solved thousands of small problems during their 2-decade development process. Competitors would have to solve those same problems themselves or find different solutions. Deere's response, when it finally came, was different from IH's approach. Instead of a single longitudinal rotor, Deere developed a twin rotor system with 2 smaller rotors side by side. This design had its own advantages and disadvantages compared to the Axial-Flow, and Deere would argue for years that their approach was superior. Case IH, formed when Tenneco merged Case and International Harvester's agricultural division in 1985, continued developing and refining the original Axial-Flow technology. Other manufacturers pursued their own variations on rotary themes, but International Harvester had an enormous head start, and that advantage proved decisive in the marketplace. The legacy: by 2013, over 160,000 Axial-Flow combines had been produced. That's more than all other major rotary manufacturers combined, a testament to both the technology's inherent advantages and IH's decades-long head start in development and refinement. Today, rotary combines dominate the market. While conventional combines are still manufactured for certain applications and markets, the vast majority of large combines sold globally use rotary technology in some form. The Axial-Flow's influence extends beyond just International Harvester's product line. The entire industry shifted. Engineering graduates entering agricultural equipment companies learn rotary principles. Service technicians are trained on rotary systems. Farmers expect rotary performance. The technology enabled larger, more productive farms. A single Axial-Flow combine can harvest what might have required 2 or 3 conventional machines. This contributed to broader trends in agricultural consolidation and increased productivity that have defined modern farming. But perhaps the most remarkable aspect of this story isn't the technology itself. It's what the development process tells us about innovation. When John Deere discovered what was happening just 1 mile away, it was already too late. The Axial-Flow was refined, tested, and ready for market. The competition would spend years and hundreds of millions of dollars trying to catch up. Some never did. Today, when you see a modern combine working through a wheat field, moving at speeds that would have seemed impossible in the 1950s, harvesting cleaner and more efficiently than farmers of that era could have imagined, you're looking at the legacy of those engineers in the garage with frosted windows. You're looking at what happens when vision, patience, and brilliant engineering come together to create something truly revolutionary. The Axial-Flow didn't just change how grain was harvested, it changed what was possible. And it all started 1 mile from the competition, behind frosted windows, in a garage where the future was being built in secret. That's it for today. If you liked this video, please hit the like and subscribe button for more videos. Thanks for watching.